Yolandi was also somebody who I've worked with over a number of years, both at Intel and outside of Intel, when I've been rushing back to Australia on mixes of vacation and invited talks for her lab and others in Melbourne. So I just wanted to say thank you to Yolandi for helping me through this process of writing an article again after 10 years of PowerPoint presentations in the corporate environment. It was a lot harder than I was expecting because we actually wrote this on purpose, not as a peer-reviewed piece. It's obviously drawing on, as you will find out, some personal observations within the context of working in high tech. And therefore, I didn't think it was appropriate to put it through scholarly peer review, but it has been very heavily reviewed and much improved as a result. But I also wanted to work with Yolandi on this talk because it really was her research and her very strong archive of research and publications in the energy sector that first educated me on feedback systems and some of their flaws, which turns out to be quite relevant to the way that engineering is moving as a way of dealing with the amount of energy consumption and resource consumption we've talked about today. So Yolandi is here and can answer questions, but I'm going to take the lead and read this paper also as a slight indulgence, because when we were working in a corporate environment too, it was very difficult to encourage people to read long papers. And in fact, I think what I've seen of academia this year also suggests that most people won't have time to read this paper, even if they want to. So I'm going to do it for us. And I also will be referring to statistics that Sylvia alluded to through her back of the envelope sketches. But if you want to know more about the specifics of energy consumption and AI, please do have a look at Dawn Nafis's talk in this series in the energy part 1 discussion, because there's lots of really interesting ways that energy was being described in greenhouse gas equivalent measures that are really the thing that we want to talk about in this piece. So to begin on getting beyond net zero dashboards in the information technology sector. The IT sector currently accounts, and when I say currently, this is information and published research from about 3 years ago now, between 1 to 4% of global greenhouse gas emissions, with expectations that this will rise to at least 14% by 2040. So those who are already alarmed by these figures often compare the impact of the industry with transportation, specifically aviation, perhaps to prompt more mainstream awareness of the link between computing and fossil fuel dependence. So to address this issue, software and AI are increasingly positioned as solutions to the industry's energy consumption. In particular, the potential to use software to prioritize computer workloads according to the availability of renewable energy is quickly becoming a matter of interest for engineers designing the architecture for personal computing devices, as well as the hyperscale data center, the infrastructure Sylvia was just talking about that supports the storage needs for the cloud. In this sense, the energy and IT industries are increasingly interdependent, since engineers are now a pivotal point of influence when it comes to defining the default energy standards for technology users worldwide. And Cindy's talk also talked about some of the consequences of that. So for many years, electrical and software engineering practitioners approached energy at the level of platform and silicon architecture, where power and performance measurements are the primary benchmarks still used to sell hardware. But as companies like Microsoft, Amazon, Google, and Meta have grown business models around cloud services for data storage, they're beginning to hold sway in local energy markets. The IT sector now carries significant influence over the power use of local energy grids, leading to new kinds of scrutiny and activism. Software engineers are also defining the tools used to measure the energy consumption of companies beyond the IT sector through new product offerings that promise to measure carbon emissions to meet corporate sustainability reporting requirements. In this way, tech companies are promoting themselves as leaders in sustainability by providing the tools to track progress towards net zero goals, even while their business plans and product roadmaps clearly contribute to increased energy demand. In this paper, we combine these current developments in the technology sector and some first-hand observations of working in it to consider how environmental tools are mobilised to continue unsustainable business practices. And while it's not a formal research study, as I mentioned, our insights are drawing on a tradition of ethnography and critical management studies that I have been part of in my academic career for many years. And we're also inspired by the work of ethnographers who pinpoint the role of everyday speech and rituals to maintain a sense of reality that may be outdated in spite of the surrounding evidence that climate change is risking the very practices that are being taken for granted in those processes. So what we want to do in this paper is identify opportunities for social science researchers to participate in what is largely a secretive and engineering-led discussion. We begin by explaining the rise of green software in the technology sector as a corporate sustainability accounting aid, noting that this trend advances the established market position of large companies. We then focus on the increasing reliance on dashboard tools as a legacy of what energy humanities scholars call petroculture. That is, the knowledge, practices, and discourses resulting from the consumption of and subsequent dependence on oil. We then demonstrate how dashboard and green software tools allow tech companies to obfuscate the sustainability impacts of their operations on a global scale. And we then draw on social science research to consider opportunities for researchers and hopefully citizens to intervene in this current trajectory and partner with industry on demanding more solutions and action on the problem of carbon reduction. Our conclusion, as you will see, is that ambitions towards net zero must always involve an assessment of the lifestyle, workplace, and capitalist assumptions that underpin large technology companies, which are the result of fossil fuel legacies of management. So, to begin with what is called green software, traditional benchmarks for software and silicon engineering have long upheld energy efficiency as a necessary ingredient to advance Moore's law, which, if you recall, observed that the number of transistors on a silicon chip would double roughly every 2 years, simultaneously lowering cost and improving performance. From a sustainability point of view, striving for energy efficiency is a laudable goal, bearing in mind the simple logic of Jevons paradox. Making something easier and cheaper to use also makes it more attractive, thus escalating demand. Recent statistics on internet use bear this out. Since 2010, the number of internet users worldwide has more than doubled, while global internet traffic has expanded 20-fold. Again, citations probably a little out of date given scholarly referees. Gains in energy efficiency have been one of the reasons this uptake in computing has not been more detrimental. And Sylvia's just mentioned some of the background for that. Still, the National Science Foundation recently acknowledged that the industry is entering a post-Moore era, which is, quote, an opportunity to look well beyond power efficiency to make carbon and other sustainability metrics first-order concerns in computing. This Dear Colleagues letter from the NSF appears to heed the point made by energy researcher Elizabeth Shove. Her point is that an unreflexive pursuit of energy efficiency served to, quote, sustain, perhaps escalate, but never undermine historically contingent, but increasingly energy-intensive lifestyles. And without a more comprehensive reckoning with the amount of energy demand the IT sector is creating through the design of ever more complex computing applications, efforts to build sustainable products are inevitably limited. They're my words, not Elizabeth Shope's. So a prominent response to these sustainability challenges in the IT industry is the adoption of green software principles, championed by organisations such as the Green Software Foundation, with sponsorship from companies including Microsoft, Intel, UBS, and Accenture. This engineering-led movement addresses IT energy use by changing how, what, and where computing happens. The key proposition is that by aligning compute workloads with the availability and distribution of renewable energy on the grid, we are a step closer to a fossil fuel-free IT sector. And here I'm showing, for Australians, a grab from one of the services where renewable energy supply is captured for developers to see. And we can talk a little bit more about that in discussion, how that applies to current practices. So this idea of holding off key tasks for a later time of day has a long history. In fact, I remember growing up on Bruny Island in Tasmania, where we had off-peak power points. So some of the power sockets for our house would not work at certain times of day because on this island, the peak energy load was difficult to maintain because it was so tiny and the infrastructure was so small. But a software update in the example we're talking about here can be postponed until, say, the end user is asleep or away from their device, therefore minimising the frustration on the user as well as the tax on the planet. So we're seeing these sorts of delay tactics introduced, for instance, in Windows 11, the pre-release software updates could be timed to coincide with the availability of renewable energy, and one of our colleagues was involved in working on that feature. It's also something that you're seeing more often in phones, in the iPhone iOS release 16.6, for example. And it's true that accruing incremental energy savings through load shifting to lower carbon power matters at scale. So there's no denying that this is all a good direction. Green software advocates target developers building systems for both large and small applications, from the IT manager who's assessing the backup storage options for data centers to the machine learning expert who's looking to train a data set at minimal cost. The Green Software Foundation and other groups like Climate Tech Net or climate tech startups that you can see listed in a lot of these discussions are part of a group of regular events, forums, and discussions where the fundamentals of carbon-aware computing are being determined right now via podcasts, Slack channels, and webinars. And through these venues, web designers, engineers, and other sustainability enthusiasts can learn how to build low-carbon websites, stay abreast of these emerging carbon accounting tools, and participate in developing new standards, as Sylvia just mentioned. Sustainable computing through green software is an existential imperative for the largest cloud companies. So customers of Intel's like Amazon, Microsoft, Google, and Meta, for them, the push to efficient workload management is prompted by the overwhelming energy demands of the data center, which, as we heard from Cindy's talk, requires 24/7 runtime and absolute resilience. In the cloud business, a primary goal is to minimize latency, to reduce to a bare minimum the time users wait to transmit or access data stored in the cloud. And this is what makes it imperative to maintain this reserve army of servers idle, yet effectively on call to meet surges in demand. Now, cloud companies' ability to claim net zero carbon emissions is becoming another differentiating move in the competition to acquire customers. Unlike technology, hardware companies and manufacturers, a software company has a comparatively small operational and industrial footprint, which makes a carbon neutral claim more likely. For the largest cloud companies, a significant profit base can now be drawn upon to pay offsets for emissions that cannot be abated. And standards consortia, such as the Open Compute Project or OCP, have also been established to provide a cross-industry platform to collaborate, promote sustainability achievements and best practice. However, based on recent observation, the success of these programs fluctuates according to the time individual company representatives have available to serve on committees. And as we'll see shortly, such service is difficult to justify in the current management culture in tech, which is dominated by objectives and key results. Participation in committees, I've seen for sure, has been negatively influenced by the widespread job volatility in the tech sector this past year, where previously active members have been moving on to seek employment in other industries. So, corporate social responsibility standards that have been developed to reflect the Greenhouse Gas Protocol framework separate carbon neutral claims and the requirements needed to fulfill them into discrete, typically incommensurable targets for companies to meet. In practice, what we've seen, and I'm trying to do the cutest diagram I can for this very complex discussion, but if you look at the way that the direct sources of emissions and the downstream sources of emissions are described and illustrated here, think about an example where somebody is charged in the company with producing a life cycle assessment for a technology product, where they have to learn all about the supply chain expertise, what goes into building that product before it even is sent to a user, and who has the expertise in the company to produce that knowledge and share it with them. They're often in another organisation. So learning about the facilities, for example, where the materials are processed, is reporting through a different budget arm and organisational structure. And often these are large companies where those structures don't have natural places to congregate and share information. So even if divisions have means and willingness to share data, sometimes this is just too difficult in the course of daily interactions because of time. And one of the things that's really interesting about this situation when we're trying to create a new field of holistic sustainability reporting is that companies will have to say that there is an integrated strategy, even though it's quite clear that there are challenges in producing that knowledge together. So one example that was quite interesting in the past year was the fact that layoffs were affecting quite a lot of people in the field of sustainability. And I noticed in one particular example, I'll just skip over to this, where on the one hand, I was learning about Meta's sustainability strategy from a keynote for the OCP Regional Summit, which you're seeing here, while in a separate screen, I was seeing on LinkedIn a friend of mine who has been affected in the past year by layoffs from the sustainability team, listing just how many of the team had been eliminated in these cuts. So it's very challenging to reconcile these two realities. And one of the things I suppose I wanted to draw on in this discussion was at least how far things are developing in the scope 3 domain. So the downstream activities that a company like Meta, for example, can start to quantify, given that they do have access to user data in real time. And the rest of this paper, we will talk a little bit about the range of contenders who are vying to get ahead of regulation to become the leader in credible accounting standards for product energy use. In just a couple of years, there have been numerous competing dashboards that have been developed as a service to IT managers seeking reliable data to populate corporate responsibility documents. So here we have Microsoft Azure, which they include with, again, another version of that energy map that we saw earlier. They're a major player, of course, given the dominance of Microsoft products in enterprise, but Google Cloud, Salesforce, and HP Enterprise are all offering bespoke products as they say, solutions to measure and account for Scope 3 carbon. Now, the fact that companies' IT footprints are being connected more explicitly to board-level accounting practices is an important development. Yet the point I'm trying to make here and for this audience is the tools that are advocated to produce these reports share a troubling common feature, and that is that they're proprietary. So rather than creating transparency as a cross-industry initiative, for-profit reporting tools make the work of environmental governance another line of business. Okay, so in this section, what is a dashboard for software? Software dashboards that track resource and energy data are becoming industry consensus as the means to show the environmental footprint of operations. As you see, they're a form of data visualization using graphs, tables, or charts to render, analyze, and display progress towards zero carbon emissions. Many scholars, including some in this series, have shown that software companies and cloud service providers in particular have been early and influential adopters of carbon emissions accounting and pledges, establishing these techniques as normative practices and evidence of corporate social responsibility. That's Anne Passek. In this way, even though it's typically more energy efficient to run computing workloads locally, as Sylvie mentioned, smaller independent companies have fewer resources to demonstrate the benefits of local transmission and hosting. And due to their enormous size and budgets, hyperscale cloud companies are in a position to link their data center operations with vast investments in renewable energy, which makes for a very positive sustainability story. So here in Oregon, Meta's Prineville data center in rural Eastern Oregon took a proactive approach to securing community support for its site location, despite the clear energy impacts of its expanding footprint. Jenna Burrell has written great research on this. Similarly, Salesforce recently announced a program to fund 280,000 megawatt hours of renewable energy certificates, or RECs, from small-scale distributed energy projects in developing regions to meet a goal of matching 100% of the electricity it uses with renewables. So these firms create a sense of inevitability by claiming that their technology is essential to producing affordable and reliable carbon monitoring, as well as the storage capacity to maintain access to anytime carbon neutral data. As Holly Jean Buck has written, knowledge of a net zero state requires quite a lot of computing power for monitoring the emissions and removals and determining the balance. It's in these companies' interests then that strategies for both deep decarbonisation and carbon removal rest on computing. So the ability to claim sustainability standards without questioning the basic business tenet of increasing data consumption means the reality of growing energy demand continues in this context without comment. Yet the emissions associated with high volumes of data traffic continue to rise, as researchers have pointed out in various forums, such as the Computing Within Limits group, which has been a big influence on my thinking here. So we've heard how internet use and online services are anticipated to reach 21% of global electricity demand by 2030, with 50% coming from real-time video streaming, as we just heard from Sylvia. The steep upwards trajectory is also matched with the uptake of online gaming, encouraged again through COVID, I think, to entertain folks who are feeling isolated. But as Yolandi's work has also shown, the rise of smart home devices and the Internet of Things are similarly testing this capacity for so-called unlimited data. So the focus of green software accounting, being fixed as it is on tracking energy, means that the causes contributing to the demand for and growth of data often remain outside of critical attention. And efforts to highlight the ecological impacts of growing compute demand, for example, in the field of AI, have been notable for inspiring industry hostility and sometimes employee dismissal. So a lot of this thinking and writing we were doing at the time that ChatGPT and other generative AI use cases were being released. And these, as many people on this call would know, pose even greater problems of measuring energy use given their proprietary algorithmic models. So placing trust in cloud companies to solve the very problem of data and energy management that their own products and business model perpetuate is a questionable premise. At a time when environmental, social and governance frameworks are becoming more and more political, particularly here in the US, the net zero orthodoxy appears esoteric and technical, indexed too heavily on carbon offsets rather than elimination. As Hollybuck notes, even if the dashboard is a useful way to measure results, one of the current problems is that the wrong things are being measured. Too often the tool is being used as a disciplinary technique rather than a means to generate optimism or more creative goals about what life will be like after zero. So from our perspective, the very notion of a carbon intensity dashboard, as it's imagined in green software engineering, is an odd way to achieve net zero targets. This is because the language being used to imagine a fossil-free energy future is thoroughly entrenched in metaphors and aesthetic forms that petroleum-based lifestyles introduced and still celebrate. The dashboard keeps in place the principles of the fossil fuel enterprise and the reporting legacies established by its hierarchical practices of resource management. So here is a slight segue, or perhaps deviation, into the dashboard as a legacy of petroculture or the management regimes of mid-century corporations. And while most of us probably think about a dashboard as something you have in a car, in a vehicle that transmits to you information in a timely fashion about speed, engine temperature, and fuel efficiency, this classic human-computer interface, to put it that way, has also become a really common way of communicating to the consumer a range of other forms of consumption, including domestic energy consumption. And this is where Yolanda's work has been really important to my thinking, to show that these forms of feedback and visual cues on things like thermostats and power bills are designed to act as feedback mechanisms to encourage mindful use of resources. But social science scholarship leaves open to question whether this is fundamentally true. But for this discussion, part of what we wanted to point out is this resilience of the idea of the dashboard, which puts an individual in the driver's seat, so to speak, in charge of this ongoing flow of information and data. So the application in the corporate context, dashboards gain further meanings again when you add it to the sorts of interventions that Cindy was mentioning in her talk, where managerial control is being exercised through new kinds of practices. The Gantt chart is one of these, where organising time and tasks to optimise productivity is a legacy that precedes the dashboard. And in the tech companies today, what we're seeing are a range of different options for employees to be tracked. But one of the most important I want to focus on just briefly is objectives and key results, or OKRs. These are an agreed upon set of deliverables that managers and workers design each year that allow people to prioritise their work and their individual contributions to a broader strategy for the company. The dashboard offers a quick means of synthesising the complexity of information work when these individual components are presented in team meetings. A great way for employees to stay on track in service of larger corporate goals. So the goals are often the debate between teams as much as between individuals and managers. But also they become a way of having a conversation about a shared cross-organisational commitment, such as a sustainability strategy. And so this was the centrepiece for tracking progress on sustainability where I worked. And a lot of the ways that we spent our time in that first year of implementing OKRs during COVID, when everyone was working remotely as well, was to try and come to a consensus on which goals should populate the dashboard and how that could be done in such a way that results could be quantified. So the actual rollout of OKRs in this organisational context took at least a year to get right. Employees had to not only learn how to write an OKR, but also how to make sure that the objectives were entered in the right software tools to be read by human resources systems that then determine performance reviews. And in our team, an additional software package was added as an intermediate step for individuals to grade themselves on OKRs for peer discussion before the official recorded version went into Workday. And all of this discussion happened despite the fact that the new CEO had changed the company's strategy to a more resource-intensive building program for manufacturing that in many ways challenged the sustainability goals that we had set out and previously, that was supposed to last for a decade. So one of the things that I want to take from this example of the OKR dashboard is the way that this management technique focused on advancing goals and productivity removes the deliberation or consideration of resource use. The dashboard aesthetic, which simplifies all of the data inputs into usually a red, yellow or green traffic signal to signify if things are progressing, simplifies the environmental concerns that have been negotiated in the interest of sustainability to, as we mentioned, things that can be measured. The other consequence of this, of course, is that goals that are determined one year can be simply refreshed the next, so that if a sustainability goal is not on course, the worst outcome that can happen is really a team member may face a loss at annual bonus time. The environmental damage that arises from a failure to meet an OKR in this context goes unrecorded. So what's, I suppose, concerning about this problem right now is that this failure in traditional corporate accounting is exactly what ESG was designed to overcome. And the fact that there is now a political backlash against the use of ESG and even ESG funding and investments is a concerning trend outside of corporate contexts as well as inside. Okay, so the final points are really just on this idea of a sustainability monopoly that is determined right now by large tech companies. And in the words of Cindy's respondents in her research, those who are in tech companies who can compute as much as they want. The sheer size of the hyperscale data centers, which create profit margins that provide unique purchasing power for green energy supply, supports a transition in the way that energy and IT are now working together. This idea that it's more sustainable for most businesses to use the cloud to run their software generates a feedback loop of customer acquisition, and moving compute demand, workloads and infrastructure to different parts of the globe capitalizes on renewable energy companies' ability to help large cloud providers to expand those operations further into new jurisdictions and continue a trend of actually moving work around to avoid certain kinds of tax compliance or to benefit from certain kinds of tax incentives. So what this means for local communities where tech companies operate can be difficult to discern. One of the ways this can also work out in corporate reporting is that the average of resource use becomes prominent in the ways that the reporting works across different sites and campuses rather than the specific locations of any one facility. And that does become concerning when places like Prineville or places like the US Southwest, which is currently getting a fairly large chip boom investment from the CHIPS Act, they're in places that are already under financial but also ecological stress. So the nutshell here, and I think where I'll leave this version of the presentation, is to see the overlap between how management theories and practices, such as the objectives and key results idea that is very dominant in tech today, feed this other tendency that we're seeing in sustainability implementation in corporations, which really focuses on carbon reduction metrics and percentages and hitting goals year on year, as the language goes, but without much talk of the social and environmental context for where those numbers come from and what effects they will be having on real people and on land. So I think in the interest of time, I will bring things to a close there. But also, again, to return to this idea of what it might look like to have climate justice and environmental concerns more prominent in the mainstream discussion, I couldn't help but think about the ways in which more of the activism around the environment is starting to focus on the 1% of high energy users and people whose lifestyles and example to others is setting unsustainable requirements or setting unsustainable status for people to aspire to. And here you're seeing some of the protests around private jet travel that have been taking off in Europe, and a very important report from Oxfam and The Guardian, which showed just how outsized the influence of a particular kind of elite can have on the mainstream uptake of normative practices. I'm trying to make an analogy here to the way that high-performance computing is normalizing a particular kind of relationship to data storage and our lifestyle and workplace practices. And I hope in the discussion we can expand a little bit more on what this might mean for us as workers and consumers. And you can also learn from Yolandi, who I'm, again, very grateful for partnering on this paper and inspiring me to write things down.